Now we're going to be looking at how to graph a cube root function. Taking a look at the cubic function f of x equals x cubed, if we wanted to find its inverse, we would invert x and y, and solving for y, I would have to take the cube root of each side. So the inverse is going to be the cube root of x. So looking at this graph, the red graph is the cubic function, and here are our parent function points for that. And if I want the inverse function, the cube root, I would go ahead and just invert those points. Now notice both of these are going to be functions, so these are inverse functions. The cube root function is going to move around the coordinate plane very similarly to the absolute value, the quadratic, the linear, and also the square root function. A in front here, again, represents stretches or compressions. H underneath the cube root will be a horizontal shift. If we see minus, that means to the right. If we see plus, that means to the left. And plus k on the outside of the cube root is going to represent a vertical shift. So that's either up if we see plus k or down if we see minus k. When graphing the parent cube root function, we're going to be using the first couple perfect cubes. So taking the cube root of -8, I get -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. So plotting my parent function points, these are going to be my go-to points for my cube root function. Now when we connect these points at the far ends of our graph, it might appear as if the graph is going off in a straight line, but it is not. It's going to eventually go up and up, but remember the next perfect cube we have is 27, so it's not going to increase for a while. Now when we're talking about domain and range, let's talk about the domain and range of the inverse of this, which is y equals x cubed. Well, the domain and range of this function is all reals, which means the domain and range of its inverse, which is the cube root function, will also be all real numbers. So the domain and range will be the same for any cube root function. It will always be all real numbers. Regardless of any type of transformations that we have, it will always be all real numbers for both domain and range. So now let's translate this cube root function. I'm going to have two different transformations. I have a +1 underneath the radical, which tells me that I am shifting to the left 1. A -3 on the outside, which means I'm shifting down 3. So I have two different transformations to do. So first, let's plot our parent function points. So first, I'm going to go to the left 1. All my points to the left 1. Now I'm going to translate down 3. So I'm going to shift down 3. All the green points shift down 3. And now we go ahead and connect our dots. Labeling our points here. So now when we're looking at domain and range, remember this is very easy for a cube root function. It doesn't matter what type of transformations that have occurred. It's always all real numbers for both. So now I want you to go ahead and try this one on your own. I have two different transformations here, and then find your domain and range.